Welcome to online lecture series in organic chemistry, and we are discussing the chapter electronic spectra of complexes. In earlier video we have seen the quantum numbers and what is the meaning of electronic state. Now in this video we are going to discuss about the electronic states. Now as I said in earlier video, in a multi-electron atom there is a possibility of inter-electronic repulsion in a particular orbital. Suppose electrons are accommodated in p orbital, there are 3 p orbitals, and suppose there are 6 electrons accommodated in 3 p orbitals, then in between each and every electron there is a possibility of inter-electronic repulsion. At the same time, the electronic spins, they couple with orbital angular momenta, and due to these two types of interactions, that is interaction between the electrons and interaction of electronic spin with orbital angular momenta, there is a generation of electronic states. So electronic states, these are the energy levels resulting from both electron-electron repulsion or interaction and magnetic interactions. These are called as energy states or electronic states. So the energy levels resulting from electron-electron interaction and magnetic interactions, these are called as electronic states or energy states. Now what is the meaning of term and term symbol? In polyelectron system or in polyelectron atom, there are inter-electronic interactions and spin orbit coupling, as I said right now. The energy levels resulting from the electron-electron repulsion or interaction, it is called as term. The energy level resulting from or energy state resulting from electron-electron repulsion or interaction, it is called as term, and this is the symbol for term. This L, it is the resultant orbital angular momentum. L is a resultant orbital angular quantum number, and 2s plus 1, this is the multiplicity or spin multiplicity, and this is what is term. Now what is term symbol? The energy levels arising from different electron-electron repulsions and the interaction of electronic spin with orbital angular momenta, it is the term symbol. These are also energy levels, but in term symbol there is an involvement of inter-electronic interaction and interaction of electronic spin with orbital angular momenta. This is the term symbol. And this is the symbol for the term symbol. So L, it is the again resultant orbital angular quantum number, 2s plus 1, this is the spin multiplicity, and J, this is the new quantum number again, which is total angular momentum quantum number. Now as I said, the energy levels for polyelectron system, these are specified by a set of new quantum numbers, that is the resultant spin quantum number, capital S, resultant orbital angular quantum number, capital L, and spin multiplicity, that is ms, it is equal to 2s plus 1, where S is this resultant spin quantum number, and fourth quantum number is total angular momentum quantum number, that is J. So the electronic states, these are defined by these 4 quantum numbers. These are the new quantum numbers. Now let us discuss one by one. So first quantum number, that is the resultant spin quantum number S, also called as coupling of electron spins. Now when 2 or more electrons are present in subshell, their interaction it is represented by resultant spin quantum number, that is capital S. And this resultant spin quantum number, it is obtained, or resultant spin quantum number values, these are obtained by simple algebraic sum of the individual S values or spin quantum number values. As an example, consider there are two electrons. Now these two electrons oriented with parallel spin like this. These are the two individual electrons. Not necessarily these are accommodated in same orbital, but these two electrons are present at a particular energy level. For example, these are the orientations. Now the individual spin quantum number values for these two electrons are plus half, because both the electrons are having the clockwise spin. So plus half, and the resultant spin quantum number S, it is the algebraic sum of the individual spin quantum number values, that is sum S, summation of S. So when we take sum of these individual spin quantum number values plus half, that becomes 1. So resultant spin quantum number value for these two electrons with parallel spin, it is 1. Suppose for two electron, another type of or possible orientation is one electron spin in clockwise direction, whereas another electron spin along the anti-clockwise direction. Then the individual spin values are plus half, this is for the first electron which is spinning in clockwise direction, and minus half for the second electron which spin along the anti-clockwise direction. And the resultant spin quantum number, it is the sum of these two values, plus half and minus half. When we take sum of these two values, then it comes 0. So resultant spin quantum number value for two electrons having opposite spin, that is clockwise and anti-clockwise, is 0. Resultant spin quantum number value for these two electrons, it is 0. Now consider there are 3 electrons. Now when 3 electrons are there, the possible orientation, one of the possible orientations, suppose all the 3 electrons, these are oriented with parallel spin, all the electrons spinning in clockwise direction. Individual spin quantum number values are plus half, because all the 3 electrons, they are spinning in clockwise direction. And the resultant spin quantum number value, this is the algebraic sum of these 3 values. So plus half, when we take sum, then it comes 3 by 2, that is 1 and half. 3 by 2, this is the resultant spin quantum number. Now another orientation for 3 electron, it is 2 electrons spin in clockwise direction, whereas third electron spin along the anti-clockwise direction. So for such a orientation, the possible individual S values are plus half, these are the 2 electrons, these are for 2 electrons spinning in clockwise direction, and minus half, this is for the third electron which spin along the anti-clockwise direction. And the resultant spin quantum number value, it is the algebraic sum of these 3 values. So plus half, that becomes 1, minus half, so net or resultant spin quantum number, it will be half. So this is for 3 electrons with 2 different orientations. Now consider there are 4 electrons, and possible orientation, all the 4 electrons spinning along the clockwise direction. They are having the parallel spins. Their individual spin quantum number values are plus half, and plus half, because all the 4 electrons have the spin along the clockwise direction. And the resultant spin quantum number value, it is algebraic sum of these 4 values, and when plus half added, 4 plus half values added together, then it becomes 2. So resultant spin quantum number, it is 2. Now for 4 electrons, another orientation is 3 electrons spinning in clockwise direction and 4th electron spin along the anti-clockwise direction. In that case, for the first 3 electrons, individual spin values are plus half each, and for 4th electron it will be minus half. So individual S values are plus half, plus half, plus half and minus half respectively, and the resultant spin quantum number, that is S, it is addition of these 4 values. So when these plus half values are added together, these 3 plus half values, then it will be 3.5, and when 1 half value is subtracted, then it will be 1. So resultant spin quantum number S, it is 1. And the third possible orientation, 2 electrons spin along the clockwise direction, remaining 2 electrons spin along the anti-clockwise direction, and in that case the individual spin quantum number values are plus half for 2 electrons spinning in clockwise direction, and minus half for next 2 electrons spinning in anti-clockwise direction, and the spin quantum number value, it is the sum of these 4 values, it will be 0. So in this way, for these 3 orientations for 4 electrons, the possible resultant spin quantum number values are 2, 1 and 0. So the resultant spin quantum number is 2 when all the 4 electrons are spinning along the clockwise direction, or they have a parallel spin. Okay, so this is what is the coupling of electron spin or resultant spin quantum number, and this quantum number gives idea about the when 2 or more electrons present in subshell, then there is a interaction between the electrons, and these interactions, it is represented by resultant spin quantum number, that is capital S. In next video we are going to discuss the resultant orbital angular quantum number, that is coupling of orbital angular momenta.